let's look at example 3, where we're going to practice graphing a piecewise function. So remember that a piecewise function is defined differently for different parts of its domain. And so the graph is going to consist of separate pieces. If we were to sketch a graph of this piecewise function, f of x is x squared if x is less than 1, and x plus 1 is if x is greater than or equal to 1, then we could start with this top piece. When x is less than 1, we're going to have the same graph as the graph of x squared, which we graphed in example 2a. So we can just use that, starting where x is 1, but not including that point. So we'll put an open circle here. Then we're going to be just like the graph of x squared that we drew in example 2a. So it came through the point 0, 0, it came through the point negative 1, positive 1, came through the point negative 2, positive 4, which will be up here. And so we just make a nice little parabolic shape, making it curvy, if we're capable of that. At the bottom here, a little curvy action going on. Alright, so that's sort of our graph. That's my interpretation of the graph for x less than 1. And now let's look and see what it's going to look like. Once we get to where x is equal to 1 or greater than 1, we're going to use x plus 1 for the function. So let's pick a few points and figure out what we're going to have there. For example, we'll need 1. We can go ahead and get 2 and 3 since we have those all on the graph over here. That's enough points to figure out what's going on. So when we put in 1 into this function, it's at the bottom, it's the x plus 1. We're going to have 1 plus 1 gives us 2, so there's the point 1, 2. We're going to then come and put in 2, we'll get the point 3, we'll get f of x is 3. When we put in 3, we get 4, so we've got 3 points now. That'll give us enough information to get this line started. We're going to start up here at the point 1, 2, and that'll be a solid circle, because when we're at 1, we're going to be at 2. We're not going to be down here at 1, we're going to be up here at 2. And then we go from here to 2, 3, from here to 3, 4. Now we've got enough to connect those dots. So it's kind of like taking the identity function, y equals x, and raising it up. We've kind of like shifted it up, which we'll talk about transformations in lesson 2.6. So that's what this graph would look like, this piecewise function would look like. Or that's what it might look like on yours, since if you copy off of the, use the graph from the grid from the web page. So now on page 162, apparently it's possible, in the book they explain how you can use a graphing calculator to graph a piecewise function, just by using some parentheses to let the calculator know what it's supposed to be, what the domain is for this part, and what the domain is for the remainder. So you might look at that if you're interested in being able to know how to use a graphing calculator for that. So now another concept you need to understand about graphs, and this is really important, especially as you move on into calculus, and you would need to understand, and even sometimes will need to know this, that a graph is considered continuous if there are no breaks or holes in the graph. The graph up there in example 3 is not continuous because there's a break right here. It picks up and then continues up here. And so that graph, this graph right here in example 3, would not be considered continuous. Now, when you are graphing a function on a graphing calculator, sometimes it's not easy to tell where there might be holes. Like over here is a graph. I've graphed this function over here, and we can see, here's a piece of it over here, here's a piece of it over here. You can put this in your calculator and see what it looks like, and that way you'll have a better image of it. But we can see that there's definitely a break right here. But there's also a hole in this graph, and we can't tell where that is because our graphing calculator isn't really able to show us that. And that's why we need to understand enough about math to be able to realize that, hey, we should have put an open circle right here at -2 because x cannot equal -2. So if you look at the original function over here, so we know that we can't divide by 0, and so we can factor this denominator into x minus 2, x plus 2, and so the denominator can't be 0, and that means x can't be 2, and x can't be -2. And so x can't be this point at, so it's not, over here on the graph, we can see that it never tries to go through 2 because x equals 2 actually acts as a vertical asymptote. But it looks to go through the point at -2, but it doesn't actually. So we would need to put a hole right there. And that's going to be important for us to understand in some problems. So you got to know how to find these things.